Okay, let's talk science for the duck game. Happy game day, everyone. We're going to start, move this around here. This next week coming up, we're going to be talking a lot about the scientific method. Since much of our class is going to be working on labs and learning how to analyze our experiments, draw conclusions from what we're seeing. This next week is going to be working through some labs where we can be applying the scientific method. And so the upcoming videos are going to be about asking scientific questions, what it means to do research, the formulation of a hypothesis, how to design an experiment. So that means materials, procedures, variables. And then once you have results, how do you analyze them? We'll talk about making data tables and graphs. And then when you've analyzed your results, how do you draw conclusions from them? How do your conclusions answer the original question that you asked? So before we get into that whole thing, there's important, I don't know, pre-scientific method things. And today we're going to talk about specifically observations and inferences. Before you ask questions, you make observations and form inferences about what you're observing. It's these observations that really drive the scientific process. And so observations, it's easy. Observations are using your senses, using your eyes, your sense of sight, smell, my very large dog, taste, touch, hearing, to take in and gather information from the world around you. And so we do this all the time. In our science class, we're going to learn how to scientifically observe, or just take what we're observing and look at it in a more scientific way. So you see things every day, you smell, hear, taste, not just in science class. I'm sure in your drive to school in the morning, you could make 15, 20, maybe even if you're really observant, 50 observations that you could actually draw scientific questions from. And so we're going to work this week on honing our observation skills and trying to draw scientific questions from them. Observations come in two forms. One you do every day, and the other is more scientific. They are both valuable and give valuable pieces of information. One is not more than the other, but the first one we're going to talk about is qualitative observations. You'll notice in that word qualitative resides the word quality. Qualitative observations, you're describing what you are seeing or hearing or smelling or tasting or touching, the qualities of what you are observing. So you might describe the color of something. So with this apple here, we might describe this color as red. If we describe the color as red, we could make some decisions about what it was. If it's a red apple versus a green apple, these are important observations. Tasting something. If something is salty, bitter, acidic, basic, feeling things that are rough, smelling things, all of these you're describing what you're seeing, but not only seeing, hearing, smelling, tasting, and touching. Okay, but you're not giving them any you're not counting them, you're just describing qualities about them. So for fireworks, there's a number of different qualitative observations that we could make. For these, we can tell the color. We can see that they're orange, green, purple, yellow, blue. We could also describe the sound that fireworks are making. If you're close to fireworks, you can also describe the smell that fireworks are making. And once you're in 8th grade, you'll also be able to tell me exactly what those colors of fireworks mean as far as chemistry. Which color is sodium? Which color is strontium? Which color is barium? Which color is copper? These are all qualitative observations, important in science, and things that you do every day You observe the qualities of things, and we're going to be working towards taking those qualitative observations and making them scientific, or drawing scientific questions out of them. Okay, as opposed to the other type of observation, which is quantitative observations. You'll notice in the word quantitative resides the word quantity, and quantity is numbers. You are finding the quantity of something, the number of something. So I want to know the number of red apples. They might be red, and that tells me a lot, but maybe I need to know exactly how many there were. When you're taking a quantitative observation, generally you're using tools to measure. So you might measure the height, length, width, or height of something. You might need to know the mass of something, how much matter is contained in something. So you might use a balance or a scale. You might need to know the volume of something. So you could use a graduated cylinder or a beaker. Maybe you need to know the temperature of something, and so you might use your thermometer. The thing with quantitative observations is that your observation is counted or measured in some way. We will be working on a lab this week in 7th grade where we're going to be measuring heart rate, doing different activities, and developing some research and some following the scientific method to determine how heart rate is affected by activity. You are going to be counting heartbeats. So you're not just going to be looking at someone and saying, wow, they are really out of breath. But you're actually going to be taking their heart rate and determining how heart rate is affected by exercise. So quantitative observations, measuring an amount of something. So after you take all these observations, I bet you didn't know you were doing it, but you're actually forming inferences. Inferences are basically explaining an observation. But the deal with inferences is that you are explaining the observation based on some experience you had in the past or some knowledge that you had gained. So inferences do not have to be common to everyone. We'll talk in class about, I'll throw up a picture and there might be 5 or 6 different explanations for what you are seeing, what you are observing. So it's just really based on your knowledge. Now, you can test an inference, you can investigate your observation, and that's what the scientific method is all about. You might have an explanation for something based on something someone told you or some experience you had. That doesn't mean that it's correct. It has to be proven, and it can be proven through experimentation. So an inference is taking an observation and explaining it based on your knowledge in the past. So let's just look at a few of these. I feel like I'm in the forest. So here is an image. We could make some qualitative observations of this image. A tree has fallen. There's water. Looks like a forest. We can make some quantitative observations. We could count native and non-native species. We could determine the temperature of the water. We can calculate number of trees fallen down, and that will give us information as well. Now, forming an inference. When I look at this picture, I notice things like the rotting wood, and I'm thinking that maybe the tree was diseased and fell. You might look at this picture and think struck by lightning. You might look at this picture and think, I don't know, hacked down by a logger. Neither one is correct or incorrect, but we could actually do some investigation and figure it out. Here's another one. Actually, let's go to this one here. We could definitely make some observations here. Houses, we could count the number of houses. We could just make the observation that houses are falling into water, but we can also make quantitative observations. We can calculate the temperature of the water. Maybe it's raining, amount of rainfall. We can calculate air temperature. Inferences. I might just say, landslide. You might say earthquake. We're explaining what we're seeing. And we could do some further investigation to figure out who was right. So this week we're going to be making some observations, forming some inferences, and then starting to apply the scientific method to some investigations in class. So thank you. Hey, under 10 minutes. See ya.